So I'm just going to run through this. If you've looked at it at all, you'll notice that it's all just this last unit statistics stuff. So let's just go through them. Though not if if you're not a very computationally minded person, then this is hopefully a good chapter or a good unit for you because none of this is particularly like algebra heavy or obviously there's no trig or anything. So it's not too bad in that capacity. But number one, describe how you would perform a statistical study for the following issue, and be as detailed as possible. I don't know. Right. A college wants to determine what classes to schedule for the following semester and wants to poll its students. So we kind of talked about a few examples of this in class, but let's go over it. So and as detailed as possible. Basically, I want you to outline the steps that you perform, and that's about it. So so we want to determine, basically we just want to poll students, right? And we want to see what classes they're going to take. So the goal, so we want to understand what classes students want. It still looks blurry. I'm sorry. Let me try this again. There we go. That seems better. Goal, understand what classes students want next semester. All right, so that's our goal. Usually, when you're starting like a study or something, you'll state what, not so formally maybe, but you'll say, "Oh, I want to study this," and you want to be as like particular as possible. So here we want to study what classes, and then next semester, right? So, but we'd have to. So our population here, and I didn't tell you to list anything. Like I didn't say list the population, but it's good to note it. So the population is all students. Students, and I don't give you the college, so at the particular college. Remember, the population is everything you want to study. In an ideal world, you would always just study the population, but it's not possible. So what we'll do is we'll take a sample. And so the sample is the more interesting part. So really for this question, strictly, since I didn't list what I wanted you to state, if you listed how you would construct your sample and then ask them questions, that would probably be sufficient. But the more the merrier. So my sample, there's no right or wrong answer for this either. It's like any subset of the student population would be fine. So maybe what we'll do is maybe we'll just walk around campus randomly. Or we can stand. So you have a couple options, right? So earlier in class, not today obviously, but earlier in this unit, we talked about one method where you would take a list of all the classes, you would select random classes from that list, and then you'd poll every student in those classes. So you could do that way. And since you are a college running the survey, you have the power to do that, right? So if you're the college, you have a list of everything and you are able to actually go into the classrooms and poll people without, that's your discretion. So that's a possibility. So maybe I'll put that. So A, so possibility one. So select. It's important that they're random classes, and poll the students therein. All right, so that's possibility one. That's a fine way to do it. Possibility two. So possibility one, this works really because you're college, as I said. But if you were just a few students and you wanted to poll students and see what classes, you could just stand like in the yard. What's it called? The common area. So you could stand in common area. Areas, hallways, residence halls, etc. You could just stand wherever you could, really, where students move to and fro, and you could just ask them questions.
Because the hallways and stuff like that, could that be considered biased just because of like commuters?
Yeah. That's a good point. If you did just do random, if you just did residence halls, you would be biased against commuters because they don't live in residence halls. So that's true. Yeah, so all these are all, just because they're possibilities doesn't mean they're good. But yeah, some are better. This is probably the better one. Number one is probably the way you'd want to do it, but you know, there are more options really. And yeah, I mean, and obviously if you're physically talking to people, then you're not even attempting to poll online students. So I mean, I don't online classes weren't that big in the past, but I'm sure they'll be larger now. So you know, you'll want input from everyone. So if you have online classes on this campus, you would also want to figure out a way to pull them in both of these situations, really. um, yeah, cool. So anyway, any way you construct a sample, there are more. You could also, if you have like a campus has Blackboard, then you could just put a poll on Blackboard, but that also has its limitations, right? Because you have response bias. People who respond to your survey might have different opinions than those who don't. So people who are willing to take a few minutes out of their day to respond to a survey about what classes they want next semester might be different than the people who don't respond, right? I don't know. They're probably better students, really, or just really more bored. I don't know. So that's our sample. And then the question, you just wanted to kind of describe what you'd ask. So you kind of would ask, so you'd ask like, and you can be as explicit as you want. You can literally put quotes around what you'd actually ask, or you could just kind of say you'd ask them what classes. So you could just ask, so poll each student as to their needs, their class needs next semester. There you go. All right. That's about it. If you wanted to, it's hard to really get into like doing number crunching because we don't have any numbers. This is a fictional situation. So that really, I'm just looking for you to describe how you generally do it. Right. Make sure you tell me how you're getting your sample. That's it. Any questions for Juan? Okay. It's kind of open-ended. So I don't know. I'm not a huge fan of open-ended questions. They seem like they have too many answers. All right, 2. You want to conduct a poll of shoppers at a certain department store, determine whether the given samples are representative of all shoppers on a given day. Explain your reasoning. So remember, like we were just talking about with bias against commuters, this you're representative of all shoppers. You want to not be biased against any subset of your shoppers. So I don't need to rewrite these. We can just do them here. So for the first one, the first 25 people to enter the store in the morning, what could be a problem with that?
Only old people.
Only old people.
Or yeah. Only morning people.
Oh, why not both? All right, only morning people. Right, and so, you know, it's just like if you've been to Walmart at 8 or 6 a.m. versus, you know, like 1 a.m., the crowds are just entirely different. So that's what you're missing. You're getting all the 6 a.m. crowd, which could be old people, and you're missing the 1 a.m. crowd, which is like, I don't know, drunk Bana students or something. All right. Every 10th person to enter the store. Is there any bias on that one?
It could be online. Like
you could be, yeah. So no online shoppers. So basically, we're just looking for people that are excluded when we do this kind of sampling. So, and yeah, no online shoppers. But if you don't have online sales, then this is decent. Every 10th person, it's probably the best one there. Everyone who buys a dress is obviously biased against like males or people who don't buy dresses. So only women, generally. That one's not too bad. And then people shopping.
My husband's buying a dress for his wife.
You could get a few of those, but really, there's probably not many of those. And then I guess some men might kilts count as dresses, but I don't think Kohl's sells kilts. So, and then people shopping in the store as you walk around at 3 p.m. I don't know. This one's not as clear. But this one and the morning one are kind of similar. Like you're only getting people at 3 p.m. So, you know, students, for instance, aren't going to be in your store, depending on the district. When they get released, they probably won't be in your store around 3 p.m. You're not getting like teachers or anyone who works until like 5 really. So you're only getting people who are free at 3 p.m., which is certainly a subset of the population. So so getting only people free at 3 p.m. So, basically you're working 9 to 5. You're not included in that sample because you're at work at 3 o'clock. So, right? So anything like that's okay. And if I ask you again, you just want to kind of explain yourself. A lot of these questions are not so much mathy as they're just you're using words to explain your reasoning. So if you explain yourself sufficiently, you'll get full credit for anything. All right. All right. So that was the sampling bias. And the first one was just kind of basic sampling or statistics, population, sample, what the point of statistics is to have a study. And now this third one is getting more into other sources of bias. So, and again, explain your reasoning. For all of these, like on the test, make sure you just explain yourself. If you give me one word and it's wrong, I can't really give you much partial. But if you give me like one word and you give me a lovely explanation, I can give you a lot of partial. So. A company selling vaping products finds a study that shows vaping is less harmful, or funds a study. Sorry, a company selling vaping products funds a study that shows vaping
That
is
like self-interest.
yeah, self-interest. Do we have another name for it? I don't remember. Again, this is one of those things. If you don't remember the exact name we use, it doesn't really matter. Those names aren't like canonical or anything. We, as long as you describe it. And so basically the idea is that the company is selling vaping products, and so they want people to buy that. So you have bias there. And as I said, if you forget the name, just explain it. Like they want people to buy more vaping products, so they're inclined to kind of bend the result. Now they aren't necessarily lying; they just might be misinterpreting data, which I guess you could consider lying. They might be, phrasing things in a very misleading way. The results might be technically correct, but they might just be screwy. All right. A government study is designed to determine the percentage of taxpayers who understate their income based on people who had their taxes audited.
I mean, what about the people that don't have their taxes audited?
Exactly. So this is a type of sampling bias because your sample is people who had their taxes audited, right? So their taxes are going to be more messed up than the people who didn't. If you don't have your taxes audited, your taxes are probably generally okay. But if you had them audited, there's a good chance that something's off with your taxes. So although apparently sometimes they do it randomly, I don't really know. But yeah, so it's sampling bias.
My mom had her taxes audited a couple years ago, and it's all because the person that she went through spelled her last name wrong.
Was that it?
Yep.
Wow.
Like all of her information was fine,
Yeah.
but her last name's Claxton,
Mhm.
and she for some reason thought it was Claxton. Now
Oh.
there's an S at the end,
Yeah.
and they just spelled her name wrong.
Well, I hope it was a simple matter, but probably
Yep.
not.
The whoever was doing it just called my mom and had her verify some information.
Oh.
And we're like, all right, go games.
Oh, well, that's cool. Well, that's good then. I'm glad they didn't make a whole thing out of it. No, I think my father was audited once, like decades ago. I don't remember. I was too young at the time, so I don't think it was that bad either. But yeah. Anyway, so yeah, so basically you're missing people who haven't had their taxes audited. And so what's going to happen if this is your study, then your study is going to say that people generally overstate their income much more than they do, right? Because people who get their taxes audited might be more inclined to overstate their income. So you're going to kind of have a bigger number there than in reality it is. And the last one, to gauge public opinion on whether capital punishment should be legal, a survey asks people, do you support legalized murder?
Response bias.
Yeah, response bias, definitely. So you're going to have people responding. The people who respond might feel more strongly towards the issue. So you might have people who are totally against the death penalty, and so they'll get their responses more. You might also say that the wording is questionable, right? So usually you would say, do you support capital punishment? Or usually, I think that's how you'd really say it. I mean, it's just a euphemism, but for legalized murder. But saying legalized murder, it kind of has a weird ring to it. So, so response bias is definitely one. And then if you wanted to go a little more into it, wording might also be one, because someone might be for capital punishment but not legalized murder. They're the same thing, but it's just the phrasing. Seems odd, right? Again, any questions with those three? So as I was saying, again, if you can't remember the sampling bias, if you can't remember self-interest or response bias or wording or anything like that, just describe what the problem you think could happen with it, and that's definitely sufficient. All right. So the next one, a math class consisting of 20 students gets the following grade. So you get a ton of grades. All right. So we want to do a bunch of things. Create a frequency table, create a bar graph, and then create a relative frequency of each grade. Basically, we want to make, a frequency table, a bar graph, and a pie chart. All right, so 3 things. And I think these numbers are different.
When we're doing this on our test for like the pie chart, can we just kind of freehand it?
Yeah. Oh, yeah.
Write what it is.
Yeah. Totally. No, you don't have to be very precise. You don't need to bust out a what is that thing? A protractor? Is that? I don't remember. No, it doesn't matter. The angle measuring thing, it looks like this thing? It looks like a sun coming up. I haven't used one since high school. But let's do this. So,
A sundial?
huh?
A sundial?
It looks like a sundial, but it's for measuring angles. It's like a half circle. And
Oh,
it has
a protractor?
Is that a protractor? Okay, never mind then. I think it is. What's the thing you draw circles with? A compass. All right, we figured it out. Never mind. Let's do this. So for the frequency chart's the easiest one, because the frequency chart, all you're doing, remember, is you count the frequency that which each category appears. So remember, we had different kinds of data. We had quantitative and qualitative. Quantitative was anything numerical that you could average, really. Qualitative is anything that fits in a category or a bin. So the letter grades you can't average them really without converting them to something quantitative. So we would say they're qualitative. And so for anything qualitative, I guess for anything quantitative too, but it's less used, you can create a frequency chart just by counting how many times the item appears. So 1, 2, 3, 4. Oh yeah, and they're in order. So just 4 A's. We determined last time that I can't count. So B's, 1, 2, 3, 4, 5. 5 B's. I hope I changed this data. 1, 2, 3, 4, 5, 6, 7 C's. I think I did. 1, 2 D's. Yeah, I did. And 2 F's. All right, so I just tallied them up. You just count. Nothing crazy. And that's my frequency chart. I guess you could put like letter grade and then like the number. I don't know, frequency maybe? Sounds better. Yeah. It doesn't really matter what you label. The whole point is that you're just counting though, and counting the frequencies. All right, so that would be, should I number these? Yes, that would be A. So it says create a frequency table. And then bar graph for the grades is B. So this is A. This is B. So it's a bar graph. Remember, a bar graph, we had what? We had a bar graph and a histogram, right? And the histogram we used when the data was quantitative, so you can put it like ordered on a number line. And then this one we used when it was qualitative, so it was kind of like bam, 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 and it wasn't really an order. I mean, I know that the letters can be ordered, but strictly speaking, there's not really too much of an order. And so when you draw your bar graph, do like a plane. You can label things, letter plane or letter grade, frequency maybe. Sounds good. And you just put them on, and we go from the lowest is 2 and the biggest is 7. I'll start at 0 and just go to 7. 1, 2, 3, 4, 5, 6, 7. It's a little low, but that's okay. And if you're when you're doing your test or your final, just you can do this on a sheet of paper if you're using Word or something to do the rest, and just take a picture of it and kind of send it to me somehow. But And then you just plop them in. So for A's, I have 4. So I'll do like a, and again, the order doesn't really matter because these are categories. They're qualitative things. So we're not putting them in an order. You can put whatever order you like. I don't know. It feels weird doing A over here, but it doesn't matter. So maybe I'll do it. So A is here. So there's 4 A's. Right. And then there's 5 B's. 7 C's. Sounds all right. 2 D's. And 2 F's. Right. That's your bar graph. So that's B. Any issues with that? Right. And then C, finally. For C, it says compute the relative frequency of each grade. So remember, the relative frequency is just the relative frequency. So equals number of items in the category. Oops, over that. Over total number of items. It's just a percentage. In this case, this will be a decimal, but you can do like times 100 to make it into a decimal or a percentage. And so it's just percents, right? We've talked about percents. It's part over the whole. And so that's just relative frequency. So in this case, for instance, we have, I don't know how many things we have. We have 4, 8, 13, 20. Do we have 20? We have more than 20? 4, 8, 13, 20. I guess we have 20. We have 20 things. So for all my relative frequencies, I'll do over 20. I don't know why it seems weird to me that we have 20. No, we're good. All right. So so for instance, so for the relative frequency, so relative frequency of A. So the number of A's we had was 4. So there's 4 items in that category. And the number of items total we said was 20. And then times 100 to get it as a percent. And I guess we could probably figure that out. It's 20%, but if you wanted to, you could do 4 divided by 100 or 220. Sorry, times 100. 20%. I hit it twice. I'm sorry. It's 20%. And then you just keep going for all of them. And if you do them all correct, then in the end, they should all add up to 100% because they're all part of the same pie. For the B's, we had 5. So 5 over 20 times 100. So again, you can just use your calculator. 5 divided by 20. Oops, no. 5 divided by 20. And then times 100. That's 25%. I did it again. Times 10. There you go. 25%.
Question, could you just have all of the points be worth a half of one? Since there's 20 of them. So like 4, like...
Yeah, that would work too. Yeah. That's a
You know
clever way. Yeah, so like 7, what's 7? So she's saying that since you have 20 of them, then each point, so if you had 10 of them, each point would be worth 10%. But since we have 20 of them, each point is worth 5%. Is that right? Yeah. Oh, that's another way to do it. So you just multiply each by 5, which I guess is quick as well. However you want to do it. This is the algebraic way. If you have a weird number of items, then you have to do it this way. But yeah, that was pretty clever. So in this case, it's 35. You just divide it by 2, I guess, right? 3.5 and then times 10, 2.5, 2. So what is D? 2 over 20. Oh, that one's just 10%. And the same for this one. There you go. That's kind of cool. And if in the end, you should add them all up. I mean, you don't have to, but when you add them up, they should all add up to 100. Oh, luckily it does, right? So those are our relative frequencies. And I actually we would make a pie graph now. And so I'll make my pie graph over here maybe. Right. So it's just freehanded. You don't need a compass. And then just also freehand the percentages. Some of them might help you. Like 25% is a quarter of it. So that one's easy. So that was 25% or B. And I like to label the percentage along with the category. 20%, so that's gonna be a little less. So that's probably too little, but that's okay.
No, do you want us to do it by percentages? Or like with mine, I just wrote like 22457.
Oh, that's okay too. Yeah.
Because I could just freehanded it and drew some lines.
What do you mean?
Like I made a circle and then I did like the smallest one. And then
Okay.
another small one, and then I did a 4, and then I did a 5, and then what was ever left over was the 7. Like
Oh,
not
I see. You somewhere on your sheet, you do need the relative frequencies for each grade. So like you have to compute these. So these are called the relative frequencies.
okay.
Yeah. So you will need those. I don't care. It doesn't matter to me if you actually list those on the pie chart. Like you could have just put B and then there were 5 for B. So you could put 5 there if you wanted to. And you could label them with the individual number of grades, or use the percentages. But you do need the frequencies, the relative frequencies. Yeah. Otherwise it's a little tricky to see. I mean, we're still gonna rough it out. We're still doing it kind of rough, so you'll probably have almost the same picture that I'll end up with, but it's just, I want to see the percentages. And then C, what is C? 35%. So, and then we have 10 and 10. So maybe I'll do like that, and then that. Again, my thing's not accurate, so don't take it super serious. 10%, D is 10%, and then C was 35. Okay. Also note the order doesn't matter to pie chart. So if you shuffle, when you're doing yours, there's no rhyme or reason to where you put anything, just whatever works for you. So like you know what I mean? Like the B doesn't have to be next to the C, and it doesn't matter. So, although, yeah, because like mine doesn't go in order: A, B, C, F, D. It's okay. That's my pie chart. Any questions about the pie chart? Okay. Let's see. Oh, this one we might not need paper, but let's try. So that was 4. The next 2, well, this one is about another graph it's just a variation on a graph. I don't know. And then the next 2 will be scatter plots. So if you break it down in your head, the first handful are about statistics, the next 4 and 5 are about graphs, and then the last couple about scatter plots and like correlation and stuff. But let's try this one. This one, we're just reading information from the graph. And I briefly talked about a graph like this at the end of class. It might have been the same graph. I don't think it was though. And so the way you want to read it is that each of these little chunks is a part of the federal spending, right? And it goes year by year, and it gives you the percentages. But it's all stacked on top of each other. So for instance, if I wanted the Social Security spending as a percentage of the budget in 1990, I would go to 1990, and then I would have to go up and figure out how big that chunk is. So for instance, on the top, that was hard to approximate.
So this is like 5 graphs put into one.
Yeah. So like if I had a straight edge, what do I do? Here we go. So like if I wanted to figure out what percentage Social Security was in 1990, I would have to figure out how wide it is. So I'd have to go over. So like it's almost 50% on the dot on the top. But be careful. You might be inclined to say that Social Security was 50% of the budget in 1990, but it wasn't, because it only goes down so far. So if I go to the bottom one, it is 30. So it's almost on the dot too. It's pretty exciting. So the bottom's 30, the top is at 50. So that means that Social Security was 20% of the federal budget. It was the 30 to 50. So that's 20 difference. So it's 20%. So that means that in 1990, Social Security is 90%. All right. So that's how you have to read this kind of graph. And the same, if you wanted to read any, the only one that you wouldn't have to do that with is national defense, because it's on the bottom. So you'd always just be subtracting off 0. So, but it's just a special case. All right. So in this question, I say, what year did national defense make up the largest portion of government spending? And so what you kind of approximate it, but you kind of look at the graph.
1968.
It looks like it, yeah, right around here, where it kind of peaks at the top. And yeah, so you just look for when it's, in general, you're going to look, if you're looking for when one piece was the biggest, you just look for where the widest it is year by year. So 1968 looks about right. All right. I don't know why. I wonder, I don't know what it would be like if you went back to 45 and 44. I'm assuming it would be astronomical. But this graph ends there. From 1966 to 2016, how has Medicare spending changed? So one of the purposes of these graphs is to help you visualize data over a long period of time, and more importantly, see how it varies and how it changes. So like this question, that's why this question's on here. It's getting, so like if you look at Medicare, right, it starts off as this little sliver, and then it kind of floops up bigger, bigger, bigger. Floop is a technical term. And it's really not, it's quite large in 2016. It's not quite as large as national defense. It's not quite as large as Social Security. And then interest on the debt, it's not as big as, so it's decently sized, but it's still not like a heavy hitter like Social Security or national defense. But you would just say, it grows. It's almost consistently growing. It's kind of interesting, actually. Like it doesn't go, like it seems to only ever get wider. Huh.
That's because, no offense to anybody that has Medicare, but people just want free health insurance or cheap health insurance. I don't understand why we have to pay for health insurance.
Who?
Like the United States in general.
Oh, yeah, I don't understand either.
Like, you think I asked to get sick?
That's the thing. It's a tricky situation. Luckily New York State has decent health insurance for, I guess you have to be pretty poor, but it's decent. But yeah, I agree. So C, using the data from the graph, make a pie chart showing all government spending in the year 1992. So 1992 is here. Right? So what you want to do is you just want to go through and pick out and find those percentages. So if you have a straight edge, it makes your life a little easy. But you can just start. So I'm gonna do this on the next page, and I'll make my chart down here. So let's see, I'll just go through one by one, and I'll find the percentages first, and then I will make my chart. So national defense, I have Medicare, I have Social Security, I have debt, and then I have other. Other's huge. I don't know why. I didn't make this chart, obviously. I think I took it from some government website, I think. So yeah, it's only interested in these main four for some reason. I'm not sure what other encompasses, but it's a lot. But anyway, so national defense, this one, so 1992, you go and look at what it was, and I don't know, it's like there. And you can approximate it as much as you like. It's about there, so maybe 24%. If in the end we'll make it work by kind of fudging the numbers. If this was like a problem on a test, I would give you some leeway, obviously. So if you said 26, it'd be fine. Medicare. So again, Medicare is one where we have to be careful, right? Because it's in the middle. So the lowest is at 26 because we just did that one, and the highest is whatever this is. So I don't know. That looks like 35 to me. So you just subtract. So 35, minus 26. Right, so you get 9. So 9%. So we said, and once, if you're clever, you can say, oh, I just measured that lower one, right? So that was 35, I said. And so if I just measure the next one up, a Medicare, I can't see it. It's like right there, or Social Security, sorry. So this one was right here. So it's like 53 maybe. So 53 and then, what did I say it was? I forgot it. 53 and then 35, I think. So 53 minus 35, about 18. Debt. So it was 53. I keep forgetting. And then it was 75. So 75 minus 53, 22. And all right, so this is what we have so far. And what I'm going to do is I'm going to add them up and then see what we've left. And I'll say that's what the other is. And we can check to see how close we are. So 24 plus 9 plus 18 plus 22. So 73 total. And we have 100, obviously, overall. So 100 minus 73 is 27. So with any luck, the remaining amount of debt should be about 27. So let's see what we measure, if we measure it about that. So over here, I'm gonna be biased towards my own answer. So it seems a little high, so it's close enough. I'll say it's 27. As I said, if this was a problem on the test, this kind of thing is not very precise, so I'd give you a lot of leeway. But you'd want something about those, and now you just make a chart. So let's see, 24% is about a quarter, so I'll put a quarter in for national defense. 22% is a little less than a quarter, something like that maybe. Debt. Other, 27, so it's a little more than a quarter. Oops, daisy, sorry, other. Not 27. 9%, what am I missing? Oh, Social Security. So 9% is, I don't know, I'm just gonna guess. There we go, that was Medicare. So Social Security and then Medicare. So something like that, all right? Any questions? So as I said, this kind of graph is useful because what it really does is it's kind of like encapsulating a bunch of pie graphs, but for each year over a period of, how many decades, and you can see what's trends. You're looking for trends. So graphs are really useful when they show you trends or allow you to see things that you weren't able to see before. Yeah, all right, so 6. So ignore all this, obviously. So 6, using the scatter plot below, answer the following questions. Okay, so next page. So this is like I talked about the scatter plot in class. So just to jog our memories, Old Faithful is a geyser, and the length at which the geyser erupts is related to the waiting time between eruptions. So the longer the waiting time, the longer the eruption, because it's a geyser, so pressure is building, and the longer that pressure builds, the longer it will explode. Right? Let's see, so is there a correlation between eruption duration and the time between eruptions? I just said that. Basically, remember, so a scatter plot, you have two variables, in this case, eruption duration and time between eruptions, and you're plotting them on a graph. So they're scattered, it's a scatter plot. And what you're looking for is either a positive or a negative correlation. A positive correlation means that as one goes up, the other goes up, or one goes down, the other goes down. Basically, they're going in the same direction. A negative correlation means that they're going in opposite directions. So as one goes up, the other goes down, or as one goes up, the other goes down. That's what I said, but and vice versa. And so in this case, they're both, as eruption duration goes up, the time between eruptions also goes up, right? So if I'm 5 minutes, I'm almost, I'm an hour and a half between eruptions. If I'm only a minute, I'm less than an hour. So as one goes down, the other goes down. If one goes up, the other goes up. So this is positive correlation. All right, the way you can see that really quick is just, it's got a positive slope. All right. That's it. If it was negatively correlated, it would have a negative slope. The line, like this imaginary line that goes through it. Let's see. What is a possible explanation? And I just told you that too. The pressure in geyser. How do you spell geyser? G-E-S-E-R. I think that's how you spell geyser. The pressure in geyser, it builds. It's not a geology class, so I'm not going to be super particular about your answer. I just want an answer. Okay. Any questions about that one?
Would we have to just write Old Faithful because it doesn't technically tell us it's a geyser?
You could put that too. Pressure in Old Faithful. Yeah, it's a geyser though.
You know what I mean? Like if this was the Regents or something like that, they would mark us off for that.
Oh, for putting Geyser instead of Old Faithful?
Yes.
Oh, I'm not that particular.
I know you're not. I'm just saying for other teachers they might
Oh,
be.
I see. I can't imagine marking someone off for that in a math class. Um, but but yeah, yeah, you can put it however you like, as long as it's clear to me. Just some explanation. I don't know what one I'll put in the test. I might put a different one that has more of a clear explanation that doesn't involve geology. Um, but yeah, that'd be horrible if I took up points for Geyser, Old Faithful instead of Geyser, or vice versa. All right, so make a scatter plot for the following data and determine if there is a correlation. If there is a correlation, be sure to state what type, what could be a possible explanation. So same question, but, this one we have some data. All right, we didn't do this one before. The one we did last time in class was per pupil, so that's the same, but it was per pupil and teacher salary. This one is per pupil expenditure and crime rate, so different. So we're gonna see if they're related. So, and we're gonna make a scatter plot ourselves. Actually, I have room here, so I don't need a new sheet of paper. So let's just boop, boop. And as I said before, it doesn't really matter. I'll put crime rate here, I guess, on the horizontal, and per pupil expenditure on the vertical. And the tricky part with these is being careful to graph them relatively accurately. It doesn't have to be super accurate because, you know, this isn't a real thing, but as accurate as you can get. I'm never terribly accurate, but for the crime rate, the way you want to set up your axes is you want to look at the smallest and the highest number you have. So here, 128 is really low because no one lives in Maine. And then the highest is Tennessee. I don't know why the highest is Tennessee. I'm assuming drugs, but maybe. So Tennessee is the highest. It's really surprising. And Maine's the smallest. That makes more sense to me. So I'll just plot them by hundreds maybe. So I'll do 0 here. And I want to go to 700. So I'll do 1, 2, 3, 4, 5, 6. And then a little bit over 6 will be where I am basically. And I'll just go by hundreds. Oh, and I did it again. Bugger, shoot. I'm going to switch these. I did the same thing in class, remember? Crime rate. And then we'll do this PP, per pupil expenditure. Sorry about that. And we're all set. All right, so that's good. So 100, 200, use a pencil, 300, 400, 500, and 600. All right. And now for the per pupil, you do the same thing. You just got to find a good scale. So the smallest is 7,000 and the biggest is 20. So we have like 13 dashes we need. We'll do it by thousands. So, and you can start wherever. You don't have to start at 0. You can do one of those things if you want to be really retro. You can do one of those things, put a break in the graph. I remember doing this in high school. I have never had to do them in college. And then you can just start. So 7,000, I'll do 1, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'll start at 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. Great. If you have a sharp pencil too, it makes your life easy. And these are in thousands, obviously. Right, thousands of dollars. All right, and let's just plot points. So California, it's about 400 and then 11,000. So 400, you go to 400 and then you go over to 11. And you put a dot. And you don't label them really. I guess you could. It's not usual that you label. But like you wouldn't put California next to it, although I guess you could, but it's weird. Next is Connecticut at 350 and about 18,000. So 350, 18,000. You're way out there. Right. You put that. Again, we're just doing things approximately. 5, and I'll round off. I'm just doing like halves really. 550, 9,000. 550, 9,000. All right. And then what do we got? Maine is 120 and 9,000. So 120, 9,000. I think Maine might be an outlier. Mississippi, 308, 9,000, 309,000. I don't know what pattern we see here. New Jersey, 320,000. What is happening? Ohio, 300, 1,100, or 11,000. And again, I'm really rounding pretty bad, but it's just to make my life easy. The pattern here is really not immediately obvious. Tennessee, 600, 8,000. Well, I'll say 9,000, 600, 9,000. It looks like it might be negative, but it's not great. 200, 7,000. It's like, I don't even know. And then Wisconsin, 311,000. I don't know what that is. I would say there's no correlation probably. If it wasn't for these guys over here, I think it would be negative. So as per pupil expenditure goes up, that crime rate goes down. But these guys kind of screw it up. I don't really, and as an answer for this one too, like if this happens, you would say, you would just have to, again, be as clear as you can with your words. Say like, it seems like there could be a negative correlation if it weren't for, these 4 states. Like if you pluck these out, what are these even? Maine's in there, right? And then the other one was 7,000 was Utah, and then 11,000 was Ohio, and then this one, I forget what that one was, 9,300. It was Mississippi. So there's some outliers here, and you can explain some of them. Again, you don't have to go into such detail, but if you wanted to have a nice answer, you would say it looks like there's a negative correlation, but there's some outliers. There's like, but you can explain them because Maine is rural. Utah is also rural. So rural places aren't going to have high crime rates in general, really. Although Tennessee is pretty rural and they have a crazy crime rate. I don't know. It's not clear from the graph. So I mean, strictly speaking, I would just say there's no correlation. No correlation. But it is interesting, right? Because I feel like you could almost argue that Maine and Utah somehow don't count because they're so rural. Whereas the other ones, you have this more trend. So you could maybe argue like if you in high population places, higher per pupil expenditure results in lower crime rates. That's probably not true though. There's probably a lot, in reality, there's a ton of factors that kind of probably go into this that
It's
aren't
cold
being.
in Maine and nobody wants to go outside.
Yeah, it's cold. I was on the news the other day, they had a map of the spread of COVID in the United States. And like in the beginning, it was just like New York and like Washington and stuff. And then, and the whole time though, northern Maine is just nothing. It's just like, so green meant there was no cases. And so it was just green the whole time. The whole country's like red. And then northern Maine is just happily green because not a soul lives there. And it is cold. Utah seems nice though. I don't know why people wouldn't move to Utah, but yeah. Any questions? Oh wait, I have a text, or not a text, a chat. Is test number 4 due on the 18th? Yes, everything under the sun is due by Friday because I need to get things graded and put in before they grades close. So everything's due Friday, preferably sooner so I can get things graded before that. But you can do everything by then. That'd be great. Oh, another one. Hold up. Oh, no worries. Cool. Any other questions?
So all we have left essentially is like the 4-page paper, this test, and I feel like there's one other thing. The JCC assessment.
Yeah.
That's
really
all we have left.
That's it. Yeah. And then we'll be golden.
You said you're going to be posting this test tonight?
Yeah. Yep. I'll post it at some point soon, tonight. And then, and then you have till Friday. That'll be it. Post test. I'll make a note to myself so I don't forget. But yeah, and then don't forget the assessment. I do need those if and it will count as a project grade. So don't forget. It is only 5 questions, and it's kind of, I didn't write this. It's relatively nice. Like they tell you what you need. Like this one, it says no formulas necessary. It's kind of nice, and you don't need. That's when they don't need formulas. When you do need a formula, so this one here, this is number 3 or 4. It gives you the formula exactly. So you just kind of plug things in, and then some of them. This one isn't even really math related. Name 3 things besides the monthly payment that you should take into consideration. So this kind of goes back into the budgeting. Like what do you have to consider if you wanted to buy this car? Do you make enough money? Do you have enough extra money? That kind of thing. Yeah, and then it just, again, is this the last one? No, there's 2 more. It gives you everything you need, really, is what I'm trying to say. So don't be afraid of this. It's not a test, it's a project grade, but do definitely do it. All right. All right. Any questions? So are we good? If you do have questions, I'll be obviously I'm available all week. So just shoot me an email and we can meet and do some work.
Are you still going to have your office hours tonight and Thursday?
Yeah.
And are we having class Thursday?
No, Wednesday is the last day of classes.
Okay, I just didn't know if we were going to have any, like, not technically have class, but have a day, like your office hours kind of.
Oh, I can do that. Yeah, if you want, I can just hang out. And then if you have questions, you can stop by. I'll make another note. I'm going through my notepad. So Thursday. Yeah, so I'll be around Thursday, I guess. So Thursday, just be on Zoom. Class. Yeah, that works. So if you have extra questions, too, I'll be online then as well. Because tomorrow, Wednesdays, I don't have a lot of free time. But if you need help, shoot me an email. All right. But yeah,
all right, thank you.
Yeah. Everyone have a great semester or great break. I mean, have a nice spring semester. All right. Bye.
Hi, Matt.
Oh, hi, Gary.
Hello.
How's it going?
Oh, pretty good. Did you still want to get together tonight?
Yeah, at 7.
Yeah, that sounds good. Yeah, we're about to eat, so.
Yeah, me too, actually.
Yeah.
I'll see you then.
Okay, Matt.
Yeah.
Talk to you in a minute.